Okay, we are live on the YouTubes. Let me just put this video in the right folder before we get going. And we can really start everything. You guys are to say perfect. Okay, so let's get started on 1.6 and 1.7. 1.6 and 1.7 is over rules of exponents. Now, I'll tell you, of all the tests we take this semester, so really, 5 tests in the final, or is it 6? Maybe 6 tests in the final. Yeah, 6 tests in the final. Of all the tests we take, this one will have the topics that are just completely opposite. 4.1 does not blend with 1.6 and 1.7. And the reason is it doesn't matter where I put these two topics, they wouldn't really blend with any test. So I put them together in 1 week. And this should be a review. If you guys are coming from like a developmental 1 class, you saw this already, actually. This should be a review from the exponential section. If not, I really treat it like you really haven't seen it in a while. It is, I mean, if you've ever sat in a math class, you've seen some of this stuff. It's just that it's been a while. Okay, so let's get started. Let me move over to the desktop camera. You guys remember, if you have questions, just ask, but I can see the chat. So I don't know if I'll hear it, but I'll definitely see it if you post something in the chat. Okay, so where do we start? Well, 1.6 and 1.7, again, goes over the rules of exponents. And I'm going to follow the order of your book, and I think it starts on about page 49. But the first rule is the product rule. Let me get this kind of situated a little better. There we go. Product rule. And the product rule says, look, if you're multiplying 2 exponential terms, I guess I need to define exponential term. Let's define that. So an exponential term would be something like a to the m. This would be an exponential term because it has a base a and an exponent m, okay? So we call this an exponential term. It's a single term. Now, if you're multiplying 2 exponential terms with the same base, so we've got AA here, right? These bases are the exact same. If you're multiplying them, that means you actually add the exponents. So you wind up with a to the m plus n, okay? So if the product rule states if you're multiplying 2 exponential terms with the same base, you just add the exponents. So let's look at kind of a string of this. So let's say we had 4x squared times x to the 9th. Okay. Now look, we really have 3 terms going on here. We've got a coefficient of 4 that's being multiplied by the x squared, that then's being multiplied by the x to the 9th. So 2 of these terms have the same base, the x's, okay? So what that means, because these are all being multiplied, they have to be multiplied, not add, subtract, or divide, but multiplied. Because they're being multiplied and we have the same base, we can add these 2 exponents together. So 4x to the 11th, okay? 4x to the 11th, kind of neat. Now be careful, sometimes this is hard to see because the base might be a number. So if we had something, I think your book maybe, yeah, your book does something like, let's say 2 squared times 2 to the 4th, okay? 2 squared times 2 to the 4th. Well, the base is 2 here, and we have this kind of pattern recognition. We have great pattern recognition skills actually as humans, but our eyeballs see the 2 and the multiplication sign in the 2, and we think we need to multiply it. But we don't. Just like up here, we didn't multiply the x and the x together, right? We kept the x and we added the exponents. We're going to do the same thing if our base in our exponential term is a number as well. Hold on. So if we have 2 to the 4th, or 2 squared times 2 to the 4th, we're just going to add the exponents together. So we get 2 to the 6th. Now 2 to the 6th winds up being, I believe, 80 or 64. 2 times 2 is 8. Yeah, 8 times 8, yeah. So this winds up being 64. But if, let's say on the test, if I want you to answer it in exponential notation, or if it's a multiple choice question, and they're all in exponential notation, that would be the answer, okay? That would be the answer to simplifying one of these. Okay? Questions so far, comments, concerns? Okay, so let's kind of do some with more than one grouping. Let's say we've got 2x y squared x to the 4th y to the 10th. Okay, so now we've got this string of exponential terms and a coefficient here, right? Remember, these are all, even though I didn't write it, these are all being multiplied. It's assumed if there's no really algebraic notation there that it's multiplied. Thirsty. So now look, the 2 can't multiply to anything, so it's going to stay put. But we've got an x and an x to the 4th. Now remember, if the x is by itself, really just has an exponent of 1. Okay, not 0. We'll get to that here in a minute. But we've got an x raised to the 1st power. So I'm going to write the 2 first because it is a coefficient and nothing else is being multiplied to it. So, and then we got x to the 1st and x to the 4th. Well, that's going to wind up being x to the 5th. Okay, 1 plus 4. Now we got these y's here, right? So y, and that's all being multiplied, y squared y to the 10th. That winds up with y to the 12th. Now, I'll tell you, one of the very common questions I get in this section is, Mr. Shirley, when do I stop? Okay, when do I know to stop? Because we'll see, we're going to add a lot of rules today to these exponential rules. And the rule is, look, you stop whenever there's no repeating bases, okay? When there's no repeating bases. We got an x to the 5th and a y to the 12th and a 2. None of the, really it's 2 to the 1 if you want to think of it as an exponential term, okay? But none of these bases repeat. If we look over here, the bases repeat, right? We got an x to the 1 and x to the 4th. That means we have repeating bases. That's what that terminology means, okay? So we could not have stopped here because we had repeating x's and repeating y's. So once we combine them, they're not repeating anymore. We got 2xy, we're done. So the first rule on knowing when to stop, if you want to write this down, is that there's no repeating bases, okay? So let's look at some other ones that just kind of look different, but they're not crazy. Let's say if we had parentheses going on with multiplication, let's say we had 2x to the 6th times, let's say 4x to the 9th, okay? Now, this looks goofy because it's being multiplied, but look, it is the same as the one above it. Everything in here is being multiplied. It's not distribution, because with distribution, you actually have addition or subtraction. I mean, I guess you can think of it as distribution, but you would just distribute. I don't know. Now, don't think of it like distribution. This actually means everything's being multiplied. These parentheses just grouped it. But remember, with order of operations, you would do what's inside the grouping first. Well, we can't multiply 2 and x to the 6th. We got a number and a variable. Like, they don't multiply together. You just smush them together with a multiplication sign, right? So because of this, like visually, I'm going to show you this is the same as saying 2 times x to the 6th times 4 times x to the 9th. Okay, it's the exact same thing because there's no addition or subtraction. Now we can multiply things through. So let's do that. Look, we've got repeating bases here. We got x to the 6th and then x to the 9th. And look, these are just numbers. 2 and 4 we can multiply together. That's just 8, right? So 2 times 4 is 8. X to the 6th and x to the 9th, that becomes x to the 15. Okay? Not too crazy. Questions, comments, concerns? Okay. The next rule your book goes over, so that was the product rule, if you're kind of keeping up. The next one is the zero exponent. Actually, they didn't even call it rule. It just says zero exponent. Zero exponent. Okay. The zero exponent, turns out anything raised to the 0 power is just 1. So if we looked at, I mean, it doesn't matter. We just have to be careful. Like your book says 7 to the 0. Anything raised to the 0 power is just 1. I'm going to tell you, you have to be careful here because we have to be careful with parentheses, because if we had -7 to the 0 power, that 0 is only attached to the 7. So therefore, when I work this out, this actually winds up being, we have to raise the 7 to the, remember PEMDAS? Please excuse my dear Aunt Sally. First, it was parentheses. This is order of operations. First, it was parentheses. Then it was exponents. That negative out front is really -1 times 7 to the 0. Okay? If you have a negative out front of anything, it's really just -1 times whatever is being negated. Well, please excuse my dear Aunt Sally, the order of operations says we have to do exponents before we do the multiplication. So we have to raise the 7 to the 0 power first. So we get 7 to the 0, we just did that, right? And then we multiply -1 times a positive 1 winds up being -1, okay? Now, if we need the entire term to go to 1, we have to use parentheses. So we have to be careful. Look, and I'll tell you, the reason I'm going over this one little spot is mainly with the calculator. When you're using that calculator and you have exponents, you have to write that exponent correctly, right, and the base correctly. If the whole number, the -7 is our number here, right? If the entire number, -7, is being raised to the 0 power, if you're putting it in the calculator, you have to use parentheses. And that calculator has parentheses. I would show you, but my 14-year-old son borrowed it yesterday for his math class and did not return it, of course. So, but if you look on that calculator, you can see there's parentheses. And if you put this in your calculator, if you put -7, here's how I would write it in the calculator. Parentheses, -7, there's a negative button in there. Kind of, excuse me, I believe it's towards the bottom. That caret button in the calculator, that means exponent. So caret 0, you'll see this winds up being a positive 1. And it's because the entire number is being raised to the 0, not just the 7 like up here, okay? The entire number is being raised to the 0 power. Okay, great. Now I'm going to come back to that actually in just a second. But before I do, let's talk a minute about the quotient rule. So we've gone over power rule or product rule. I think they call it product rule. And then 0 rule. Now let's go over the quotient rule. So the quotient rule. The quotient rule says, look, remember if we were multiplying, we add the exponents. Well, if we divide here with this quotient, we're actually going to subtract the exponents. So if we had, let's say, x to the 4th power over x, okay? Something kind of basic. X to the 4th power over x. Ooh, I need to put my phone on the side. If we have x to the 4th power over x, turns out we just have to subtract. Now we have to have the same bases, just like before. We've got the x as the base. All we have to do is subtract the exponent. So 4 minus 1, we wind up with x cubed. Okay, now this really comes from the fact that if you multiply these out, x to the 4th is x times x times x, right? And x to the 1 is just x. It comes from simplifying. If all of our numbers are being multiplied up top and on bottom, we can just cancel 1, right? Because there's 1 on top and bottom. And this winds up with x cubed. That's like the visual way of doing this. So instead of having to do this over and over again and write out numbers, long ways in exponential form, someone really far back realized, hey, we can just do a little shortcut and just do subtraction. Okay, so let's look at a few of these. So if we had, let's say, 3x to the 5th y over x cubed. So 3x to the 5th y over x cubed. Now notice there's only an x on top and bottom. That 3 and that y don't have anything to combine with. And we still have the same issue. These are repeating bases. Now I know they're not being multiplied, but they're actually being repeated on top and on bottom. And everything's being multiplied on top. Okay, everything's being multiplied on top. So what that means is we can simplify the top and the bottom. The x's, I should say, on top and bottom. Well, 5 minus 3, that's just 2. So this winds up being 3x squared y. Okay, 3x squared y, kind of neat. Okay, And notice we have no repeating bases, a 3, an x, and a y. So nothing repeats. So we're good to go. Okay, so let's look at another one. Let's do one with some numbers here. Let's say I had 5 cubed x y to the 9th over 5 squared y. Okay, this is the next one. I know you might be thinking, oh my God, this is crazy. It's not bad. We're going to break it down, and it really isn't bad. We have common bases going on in the top and the bottom of this fraction, right? We've got a base 5 here that's on top and bottom, and then we've got a base y on top and bottom. Now the x, that's by itself, right? X's should be left alone, pun intended anyway. But this x is by itself in the numerator, so we're going to leave it alone, okay? Now let's look at the 5s. We got 5 cubed on top and 5 squared on bottom. Just like before, look, we're going to keep the base. We're just going to subtract the numbers. So this winds up with 5 to the first power. The x is still there. Nothing combines with it. But now we got this y to the 9th and y to the first power, right? Remember, if y is by itself, or if a term or number or variables by itself, it's just y to the 1. So this leaves us with y to the 8th. There we go. Now look, you can leave it as 5 to the 1. That's fine. We just don't usually write exponents if they have a first raised to the first power, or exponential terms with the first power. So this would be 5x y to the 8th. Okay. Guys, I'm going to pause here for just 2 seconds. I'm going to ask if you have any questions. You can throw them in the chat. You can butt in, just like I said earlier. I'm gonna kind of, what's the right word on this? I think I lost some words here. I'm gonna make one of these a little bigger. Okay, we're gonna kick it up a notch. If you're a fan of Food TV. Okay, so let's look at one with more stuff. Let's say we've got 12 x to the 10th y over 14 x squared y. This has a lot going on, right? Now, the 12 and the 14, the coefficients out here, it's not that they have the same base. They're not the same base, 12 and 14, but we can simplify that. That's a fraction, 12 over 14, right? So we're going to have to simplify that fraction. And then we're going to have to look at the x. We can simplify the x's 10 and 2, right? And then the y's. Now, the y's are the same on top and bottom. So that'll be kind of interesting. They both cancel, but we're going to use subtraction to do this. Okay, so let's look at the 12 and the 14. 12 and 14, they're both divisible by 2. So I'm going to divide 2 on top and bottom. This is simplifying fractions. So this would be 6 over 7, right? 12 divided by 2 is 6. 14 divided by 2 is 7. X to the 10th, x squared. Oh, that leaves me with an x to the 8th, right? Now, y to the 1 over y to the 1. If we do the math and we subtract these, this winds up being y to the 0 power. Okay? So y to the 0 power. And it turns out we just learned a few pages ago, y to the 0 power is just 1. So really, I mean, it's not that it's nothing, but if you multiply anything by 1, it's itself, right? So when you're dealing with multiplication, it can just go away. So y to the 0 just goes away because it's 1. So this winds up being 6x to the 8th over 7. Because really it's times 1. We just don't write that. Okay? Questions, comments, concerns? Oh, man. Okay. I must be great at this. That's the quotient rule. Okay, the last thing, well, not the last thing. One of the last things, I think this is the last exponential rule. Your book goes over in this section, is the negation rule. So negative exponents. Then we kind of combine a lot of stuff in. I need to get some new markers. I haven't got any markers since last semester. They're all just starting to dry up. So negative exponents. Okay, so negative exponents, the rule actually looks like this. If you've got anything raised to the negative power, you can actually move it to the denominator, okay? And it turns positive. Anything raised to the negative power, you just move to the denominator and it becomes positive, and vice versa, actually. So if you had anything negative in the denominator, you just move it up and it becomes positive, okay? It's a vice versa kind of statement here. So any negative exponent, you move to the denominator, it becomes positive, and vice versa. If it was negative in the denominator, pop it up and it becomes positive. Because, look, remember I said a few minutes ago, we can't have repeating bases, right? Here we've got repeating bases, so we know we're not simplified. This exponential term is not simplified because we have repeating x's and y's. And then in the end, it doesn't, right? It does not have a repeating base. Well, also to be completely simplified in an exponential term, you cannot have a negative exponent. So we have to know how to deal with them. So we can't have negative exponents. We have to know how to deal with them. So if we look at a basic example, let's look at a few of them actually that have both of this. And really this is more about, well, what if we wind up with it at the end of our answer? So it's kind of like, hey, what if we got to the last step and our answer looked like this? 3x to the negative 2. Okay, 3x to the negative 2. This is not simplified because we have a negative exponent, okay? Now we have to be careful. The only thing that has a negative exponent is the x, not the 3. The 3 is raised to the first power, okay? So the 3 is going to stay put, but we have to move this negative exponent with this exponent rule right here. And it says, look, if we have a negative exponent, we move it to the bottom and it becomes positive. So the 3 is going to stay put on top, okay? But the x squared is going to move to the bottom. So we get 3 over x squared, okay? 3 over x. And now notice it's positive x squared. This is simplified. There's no repeating bases, which we didn't have a repeating base to begin with. But also there's no negative exponents. We got rid of the negative exponent, okay? So let's do one with a negative exponent on the bottom. Let's say, and we're working along, and we wind up with y squared over 2 to the negative 3. That's a 2. Y squared over 2 to the negative 3. Okay, so the y squared is fine. There's no other y's, right? So there's nothing to combine it with, like up here. And the squared is positive, so it's fine. Now the 2, though, is raised to the negative 3. We can't have that. Okay, we can't have a 2 raised to negative 3. That's weird. Don't tell me it's negative 6 or negative 8. Look, negative exponents, to get rid of the negative, then we can do the exponential arithmetic, okay? But we have to get rid of the negative first. And so we're going to use this rule because it's in the denominator. Notice it's down in the denominator. So we're going to use this rule that says, look, we can bring this to the numerator and make it positive. So this winds up being y squared times 2 to the third power, okay? Y squared times 2 to the third power. And we know 2 to the third power. 2 to the third power, 2 times 2 is 4, times 2 is 8, okay? Now, we also write numbers in front of variables, so this is all being multiplied. So this actually winds up being, let me write it down here, I ran out of room, 8y squared, okay? 8y squared. Okay. So we're going to run into this throughout these next few examples. And notice, though, in the end, if we wind up with a negative on the bottom, it's got to come to the top. Or if we wind up with a negative on top, it has to come to the bottom, okay? Either way you think of it's fine. And I'll tell you, with this section, it's a little easier if we're like in class. But in this section, there's a lot of different ways to get to the same answer. As long as we follow the rules, we'll be fine, okay? Remember, the rules are, if you've got the product rule, if you've got the same base, add the exponents. The 0 rule, if it's raised to 0, it's just 1, right? It's up here. The quotient rule, which we did right here, if you divide, just subtract the exponents. And then finally, the negative exponent rule that says, look, if we wind up with a negative, you just have to move it. Really move it about the fraction, right? Move it down and it becomes positive. So if we stick to those rules, it's fine. Well, we might kind of do a few of them in different orders per se, and that's fine. There's not really a, I mean, there's not really an order of operations the same as we think of it with basic algebra. You can do some of these in different orders if you wanted to, if your eye sees it. Okay. Now, at first, if this is really just kind of a foreign language right now to you, just follow along, right? Follow me, do the steps that I do, and eventually you're going to see when you hit the homework that you're going to be like, oh, I don't have to do it exactly like that. I can kind of do this little shortcut, and that's fine. As long as we get the same answer, it does not matter. Okay, does not matter. Okay, so let's look at some that kind of combine a few of these. Actually, I'm going to do a few more examples on the negative exponent. So we've got m to the 5th over m. I'm stealing this one right out of the book. M to the 5th over m to the 15th. And I'm going to show you with this one that actually, you know what? Hold on. Erase that, or we can come back to it. We'll do it in here. Let's say x squared over x to the 5th. This one will be a little easier to show you. I'm going to do this one two different ways, and there's nothing wrong in how I did it. Okay, but I'm going to do it in two different ways. I could work this one like 4 or 5 different ways, but it doesn't matter. I just want to show you that it can be done in different ways. If you see one of them that makes sense, just stick with it. The first way I'm going to do this is what we learned already. This is the quotient rule, right? We've got an x on top and an x on bottom. So that means we subtract these, top minus bottom. So this winds up being 2 minus 5. I'm going to write it here just to write the in-between step, right? This winds up being 2 minus 5. And we know 2 minus 5 is just negative 3. Look, we combine the x's. Remember, we can't have two of different bases. We can't have both repeating bases going on. So now we combine them with the subtraction, but it turns out we get a negative exponent. Well, in the end, we can't have a negative exponent. And we know from that last rule, if you've got a negative exponent, this is really the numerator, right? I mean, if you want to think of it as over 1, you're more than welcome to, okay? There's just nothing in the denominator. So look, we can't have a negative exponent. It has to be moved to the bottom. And there was nothing up there to begin with, right? I mean, really, there's a coefficient of 1. We just don't write it. So if you move it to the bottom, it still has a 1 in the numerator, okay? If you move everything away from the top, you still have a 1 in the numerator, okay? Now, I'm going to work this one exactly the same. I mean, I'm not exactly the same. I'm going to work this one in a different way, but we're going to wind up with the same exact answer. Okay, same exact answer. So if we've got x squared over x to the 5th, well, I'm going to do it the long way. Look, this is actually x times x. X to the 5th is x times x times x times x times x, right? Okay, and then I'm just going to cancel things that match. Use another color. Why not? We got an x up here, an x right there. We got an x right there and an x right there. We can't cancel any more x's, right? So in the numerator, everything's gone. That leaves us with 1. But in the denominator, we're left with x to the 3rd. So 2 different ways to solve this same example. And so I'll tell you, my brain does it this way. Whenever we have kind of simple quotient rule here, my brain does it this way because I'm thinking, okay, I got 2 x's on top. I got 5 x's on bottom. That's just going to leave me with 3 x's on the bottom, okay? It's a more visual way of going about solving it, maybe even logical way, where this is more of the formulaic way of doing it, okay? And there's nothing wrong with it. It's just that it's just how my brain sees it. It's probably how I was taught it, you know, but it's how my brain sees it. So these next few, I'm going to stick with the formulaic way because really your book's trying to ingrain in that negative exponent. Notice we didn't do a negative exponent down here, right? This one didn't have a negative exponent at all. So the next few, you can work this way, but I'm going to work them this formulaic way because we've got to get the negative exponent stuff to make sense. So if we've got m to the 5 over m to the 15th, that's really m to the 5 minus 15. So we get m to the negative 10, right? M to the negative 10, if we move that up, which we can't leave a negative in the exponent, so it's 1 over m to the 10. Okay, 1 over m to the 10. Okay. I'm stealing these straight from your homework now. Okay, and I say homework from the book. These are going to be examples. And actually, I'm going to give you a few of these and I want you to try them. I'm going to give you just a few minutes, kind of a quiz that kind of goes over a few different things that we've done so far up to this point. So, yeah, I'll number these. Let's say for number 1, let's say we've got 3 times x to the negative 4 times x. That'll be number 1. Number 2, let's do 2 to the 4th times x squared over 2 times x to the negative 5. Number 3, let's say we've got parentheses negative 4x y to the 0 times 2 x to the negative 3. Yeah, that'll work. Ooh, okay, I want you to try those 3. They kind of incorporate everything we've done up to this point. And I'll give you just a few minutes. I mean, no, you don't have to rush, but I'll give you a few minutes to complete these, okay? Okay. If you're not done, that's fine. If something doesn't make sense, that's fine. Okay. Don't get down on yourself. We're gonna let's work through these. Make sure we understand it. Okay. And again, if you work these a little different, that's fine. Now look, this 3 doesn't have anything to combine with, so I'm just gonna write it first. We've got an x to the negative 4 and an x. Now remember, this is multiplication, so we have to add these together. So we wind up with x to the negative 3, right? Negative 4 plus 1 is negative 3. And we can't end on this one, though. we got to move that to the bottom. So we wind up with 3 over x cubed here, right? No repeating bases like we had here. And the exponent, the negative exponent, turns positive. Okay, great. Okay, let's do this next one. Okay, I'm going to show you another way to work this. And I know you're going, what, Mr. Shirley? Why? You already showed us 2 different ways. Well, if you're just not a fan of negative exponents, you can move them to begin with. So first off, we've got a 2 to the 4th and a 2 to the 1st power. I'm going to combine those. We know we subtract 4 and 1. That becomes 2 cubed. Now we got an x squared here. Look, this x to the negative 5, you can just move it to the numerator. And it would become x to the positive 5, right? So it's not that we haven't done it before. It's that we automatically subtracted here, which is 2 minus a negative 5. You'd wind up with positive 7, which we're about to get, okay? So if you did subtract 2 minus a negative 5 is a positive 5, right? So 2 plus 5. You'd wind up with 2 to the 7. Now what I did is I made everything multiplication, okay? By moving everything to the numerator, now I did subtract these, but by moving it to the numerator, I made it multiplication, which means you can add those exponents. So now 2 cubed, 2 times 2 times 2, that's just 8. And then we have x to the 7th. So 8x to the 7th power, okay? Boom, 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 boom. Oh, down here. So now, again, all of this is being multiplied, right? There's no addition, subtraction, nothing crazy. It's all being multiplied. So I'm going to just write that out. Negative 4 times x. We don't have to write y to the 0. Y to the 0 we know is just 1. It goes away. So 2 times x to the negative 3, okay? Now, negative 4 and 2 are just numbers. They're not exponents. Don't tell me this is like, don't move something to the denominator because of that 4 being negative. That is not an exponent. That's not a negative exponent, right? No, that's just negative 4, okay? It is a basic number. We're going to multiply negative 4 times 2, and we wind up with negative 8. And then we're going to multiply x times x to the negative 3. That becomes x to the negative 2, right? Remember, there's a 1 here. So we add those, but really we're 1 plus negative 3, right? Negative 2. We can't end on this because, again, this exponent's negative. So we wind up with negative 8 over x squared. Okay, negative 8 over x squared. Questions, comments, concerns? Okay, I'm going to assume you all know this. Or you saw, like, if you got it wrong, you kind of saw how I did it. That you got it right, because we are not being chatty this morning, which is super understandable. Okay, the last thing in this section, excuse me. Actually, there's 2 things. There's also simplifying the variable with exponents. So your book only does a few examples. If we had, this is actually on page 52. It's example 26. If we had like x to the 2a times x cubed, okay? X to the 2a times x cubed. Well, look, if we've got the same base being multiplied, we know we just add the exponents, but we can't add 2a and 3, right? So this would be x to the 2a plus 3, okay? X to the 2a plus 3. So it looks goofy. It kind of looks like it's not correct, but it's just because we can't actually add these exponents. If it was just 2 and 3, of course, this would be 5, right? But we can't add the 2a and 3a. So we still have to use the same rules, but we just combine them into one exponential term. So if we looked at another one, if we had, I'm stealing this one straight out of the book. If we had x to the 2y minus 1 over x to the y minus 5. So x to the 2y minus 1 over x to the y minus 5. Now on this one, again, now I'm going to think of this entire exponent in parentheses. It kind of helps me visually see it. Notice the x is raised to the 2y minus 1. This x is raised to the y minus 5. So if we wanted to combine them, it would be the top minus the bottom, right? The top exponent minus the bottom exponent, okay? And now we've got to combine like terms. Now, first, before we do that, we have to distribute that negative. So this winds up being x. Now I'm going to get rid of the parentheses here. 2y minus 1. You distribute that negative through, you get a minus y and a plus 5, right? So all of this is the exponent now, okay? All of this is the exponent now. I'm going to combine like terms. 2y minus y, that just leaves me with a y. Negative 1 plus 5, that leaves me with a plus 4. So that's my exponent. Okay, so it looks more complex because it's not just numbers now, right? We have variables in there. But in the end, you're doing the same operations. Look, this is just top minus the bottom, right? And then it turns into simplifying this subtraction, the polynomial subtraction, okay? 2y minus y and negative 1 plus 5, okay? And we combine them together. Not that big of a deal. Okay, questions, comments, concerns? Okay, for homework, guys, I'm going to stop here. We'll cover 1.7 tomorrow. And what's nice about covering 1.7 separately is you'll have time to work on this stuff. And then 1.7 will be a breeze because it's just an extension. And I bet we will have, anyway, well, hold on, let me put this down here. So let's say for homework, we've got, this is on page 55 in section 1.6. I want you to do numbers 1 through, this is going to feel like a lot, 1 through 91 odd. And I know that's going to feel like a lot, but I'll tell you, a lot of them are real quick at the very beginning. So 1 through 91 odd. And if you can't get through all of them, do every other odd. Okay, do every other odd, and then come back in tomorrow's lecture. We'll build on this topic. So hold on, give me